Alright guys, today we're going to be talking about how we can determine the end behavior of polynomial functions. So this video is going to be a continuation on the last video that we created where we made a table, okay, based on polynomial end behavior. So again, if you haven't seen that video, make sure you check it out before you try this. So they want us to determine the end behavior of each one of these functions. So the first thing we need to do is we need to determine our leading coefficient. So in this case, we're going to start with this function. Our leading coefficient here is going to be -3. Now remember, we're going to just give our leading coefficient a value of a. So in this case, if our leading coefficient is -3, and we're going to call it a, that means a is going to be less than 0. Again, this is coming from the table that we created in that last video. All right? And now we want to look at our degree. Well, our degree here is going to be 5, and that's going to be odd. So our degree is odd. So going to the table that we created, all right, if a is less than 0, and we have an odd degree, we know that as x approaches -infinity, our function, or in this case p of x, will approach infinity. Okay, and as x approaches positive infinity, right, p of x will approach -infinity. All right, and again, this is coming right off that table. And that's it. Let's try another problem here. So, if we're looking at this function, what is going to be our leading coefficient here? Well, that's going to be 5, and 5 is greater than 0. So we're going to say here a is greater than 0. In this case, we have an even degree, right? Because our degree is 6, so it's even. All right, and then using our table, we can see that if a is greater than 0, and we're dealing with an even degree, we have the following. So as x approaches -infinity, our function, or in this case r of x, approaches infinity. All right, and as x approaches positive infinity, our function, or r of x, will also approach infinity. Okay, and that is it. So that is how you determine the end behavior of polynomial functions. Again, go back and look at that table so this all will make sense.